Now, I don't know about you, but when it comes to IT, I don't look forward to manually managing TLS certificates. But certificate management is important for security. Fortunately, for public-facing servers at least, Let's Encrypt came along and they gave us automated certificate management. And while it could be used for internal servers as well, it's actually a terrible idea to provide your private IT information to a third-party public server. Fortunately, Caddy can be configured as an ACME server on your private network. Now, granted, you still have to configure your computers to trust its root certificate, but once that's done, your internal computers will have automated certificate management. But how do you configure Caddy to act as an ACME server? And how do you integrate this with a DNS server like by9 to support DNS challenges? Well, if that's something that you're interested in finding out, then stick around and watch this video, as that's what we'll be going over. Now, because this video is about configuring Caddy as an ACME server, I'm going to assume that you already have Caddy installed, or you at least know how to do that. If not, then I do have another video which shows you how to install Caddy as a container in Docker. I'm also going to assume you have a DNS server, like by9, that supports dynamic DNS updates, or you at least know how to set this up. If not, then I do have another video that shows you how to do this on a Linux computer. And I also have another video which shows you how to do this in a container. Although, if you've got another DNS server that supports dynamic DNS, feel free to use that instead. Now, before I actually get started with doing any configuration work, I thought it'd be good if we just go over the basics of ACME, but also to explain why a DNS challenge is going to be useful. So, first things first, what actually is ACME? Okay, I don't mean that ACME, I'm talking about this ACME here. Automatic Certificate Management Environment, that's what ACME stands for. And it's basically about automating that process of getting a certificate for your server and keeping that certificate up to date. Now, I've just got a very basic example here of a web server on the internet, and it needs a certificate for www.example.com. Now, back in the days, this was a manual process. You had to set up a certificate request, you had to send it to your certificate authority, and then you just had to wait. They've got to validate the certificate, make sure it's genuine, the request that's coming in. They've also got to then sign a certificate for you, send it over to you. So it took time. Then once you've got the certificate, you've then got to provision time to update the server, to use the new certificate. And then your users have got secure connection to your server because it's using a certificate that's been signed by a certificate authority that most, if not all, of the web browsers out there trust. It's just a slow and laborious process. And back then, the certificate would last about 365 days. And yeah, it meant you'd have to repeat the process every year. And it's pretty safe to say you didn't have just one server to look after. You had a lot. That is a lot of work. And there was a lot of processes went in to keep an eye on your servers, because if you didn't update the certificate, things happened, things stopped working. It was an interesting time back then. Definitely interesting. Anyway, thankfully, we've now got Let's Encrypt, who gave us ACME. So what happens here now is that the server asks for a certificate and it just looks after itself. So once you set this up with an ACME client and point it to an ACME server, it goes off and talks to the ACME server and says, I'd like a certificate for www.example.com. Now, we still need that validation. You don't want just anybody spinning up a server pretending that it's belonging to Microsoft. We've got to have automated validation that this is a genuine request. So the simplest way of doing something like that is for the ACME server to go and talk to the DNS server, which is authoritative for this example.com in this case. So it'll ask the DNS server to resolve www.example.com to an IP address. The idea is that the requester has management access to the DNS server. Nobody else does. So we should be able to find legitimate records in here. When we resolve that FQDN, we should get back a legitimate IP address. With that IP address, the ACME server here then connects directly to the actual web server on port 80 or 443, because that's the port that web servers use. Once we get a response, it's a case of, okay, well, that seems to be a legitimate request, and the ACME server can then get a certificate actually signed by the certificate authority, and then it can be forwarded over to the web server. And if the web server is set up correctly, it can then update itself with that new certificate. It doesn't really matter when the actual certificate expires, because this is all an automated process. Just before the certificate's going to expire, the server should go off and ask for a new one. Then it'll use that new one going forward, and it just keeps itself up to date. So that makes life a whole lot easier. All you've got to do is just set this up and then just forget about it. You probably still want to monitor it just on the safe side, but yeah, this makes life so much easier. Now the only thing is, this is all well and good on the internet because the ACME server has got direct access to the web server. I mean, you've set this up so that all of the public can access it, so the ACME server doesn't have an issue. But it's a whole other ballgame when we're talking about provisioning certificates on a private internal network, especially when most of those time those certificates are for management interfaces on computers. Now in this example, I've got an internal network with two computers and they both need a TLS certificate. The only thing is, these aren't your typical web server. These are computers that you manage through a web GUI. So for that reason, they're typically placed into a dedicated management network. They're then put behind a firewall, and you do not allow access through the firewall directly to the actual computers. The computers can send traffic out and replies can come back, but nothing on this side of the firewall can initiate a connection and connect directly to the computers. It's just not allowed. It's a bad security practice, mainly because of software vulnerabilities, but also it just makes your security a whole lot simpler to manage. But that poses a problem because we need to validate certificate requests for this ACME server. Fortunately, you can take advantage of what's known as a DNS challenge instead of a direct challenge. We just put a bit more work on the actual DNS server. So in this case, what happens is our monitoring server, as an example, will start the connection and connect to the ACME server through the firewall. And it'll ask for a certificate for monitor.example.com. The server will send back a reply. And again, like I said, the firewall allows replies back. But that reply says, I want to see a specific text record with this name and this value on your DNS server. So that's our DNS challenge. Now, although we know that the name of the record includes the FQDN and we know this all well in advance, we have no idea what the value is. It's going to be some long random string of characters. So for that reason, this computer here needs to be able to make DNS changes on the DNS server, and the DNS server needs to support dynamic DNS for that to take place. So there is a bit of extra work in that our client here has to do more work than before. Our DNS server needs to be able to do more work than before, but it allows us to get around this direct connection requirement. So in any case, the computer here will then create a text record based on what was requested on the DNS server. It waits a short while for DNS to propagate, assuming there's more than one DNS server out there for redundancy. And then it tells the actual ACME server to go and check the DNS record. So the ACME server goes off and does that. Assuming it sees what it's expecting, then it can get a certificate signed and sent over to our computer here. And then our computer can delete that text record because it's no longer needed. But it means that we've now got our automation in process. There's no direct connectivity from this server to this server. The big change is the fact that this server now needs to be able to make dynamic DNS changes on this server. So that's something to bear in mind. But it is a lot more secure in that respect. I mean, this server has no direct access to our management interfaces. It only needs read access to the DNS server, which it needed anyway. If it was going to resolve the FQDN to an IP address, it still would have needed read access to the DNS server. But we're just adding in this extra requirement for the ability to update and create and delete text records on the DNS server. So it's a lot more secure than the direct connection method. Just needs a bit more work. But it means that you can now use ACME on your internal network as well. Now, another big benefit of this is when you've got servers that are not listening on the standard port 80 or 443. So for example, this Proxmox server here, it listens on port 8006. That would have been a problem with a direct challenge because the ACME server would only try to connect to port 80 or 443. In a previous video when I was showing how you could use stepca, I had to do some forwarding to get it to connect to port 8006. That's not even necessary if you're using a DNS challenge here, because the ACME server, it just talks to the DNS server. It never goes and tests the web service on here. So it makes life a whole lot better, I think, doing it that way. The only catch is you really want to be using your own ACME server. You don't want to be using one of the public CAs like Let's Encrypt. So why not just use a public service like Let's Encrypt? Well, for one thing, even if the certificate management is free, you're going to need a public domain. In most cases, you'll have to purchase one, and then you have to pay an annual fee to keep it. Now, for some computer systems, the computer name has to match the certificate name, which could mean reconfiguring those computers. And if you stop paying for the domain and someone else buys it, now you've got to rename those computers again. There's also additional security risks. Unless you know what you're doing, you could end up sending unencrypted details of your internal computers to the public DNS server, managing your domain, each time a certificate is renewed. So anyone in the path can learn about these computers. But even if you do encrypt the DNS session, you're placing the names of your computers on that publicly accessible DNS server. Granted, the records aren't meant to remain long, but if the certificate process fails, you could end up with those computer names being left on the server until A, you realise, and B, you remove them. You're also providing the public certificate authority server with details about your internal devices. Even if they say they delete the information once the certificate is handed over, just like the DNS server, can you really be certain that none of that information is being logged in some other way? Lastly, there's reliability to factor in. Third parties will be managing both the certificate and DNS service. If either of these go offline, your servers can't update the certificates, and when that happens, some systems stop working. I mean, a browser, for instance, won't connect to a web server if the certificate has expired. And to get around that, you'll have to connect to the IP address instead, but this could impact other applications as well that rely on TLS. And unless you've got fully diverse internet links, and even most businesses don't, an internet outage or even a maintenance job could prevent your certificates being updated as well. So, although there's extra work required, running your own certificate authority makes a lot more sense to me. Now, because we're going to be using a DNS challenge as part of the ACME process, I need to configure my DNS server, by 9 in this case, to allow ACME clients to make changes to DNS records. Now, I've already got it set up to allow changes for DHCP servers, The only thing is what they change is different to what ACME clients change. In which case, because I don't want just any computer being able to make DNS changes, I'm going to create a completely different key specifically for these ACME clients. Now, if this had been a separate standalone server, I'd run this command here, tsig-keygen, to create a new key. Use -a as the option to tell it the algorithm. In this case, we're going to use hmac-sha256, and then I'm going to call this key acme.key. Bind9 needs to know about this key because the client's going to present it with a key, and it needs to know what that secret is based on the name and so on. In which case, I'm using T to append the output into a file I've already got bind9 configured to use. Now I've called this one dnskeys.conf. Later on, I'm going to be doing some testing using NSUPDATE, and I haven't found a way to get NSUPDATE to reference a specific key within this file. So for that reason, we're going to also create a separate file, which I'm calling acme.key. The only thing is, this is not a standalone bind9 server. It's actually a DNS container that I've got set up here on Docker. So I'm going to basically pass the actual command through to the container by running docker exec, then the name of the container, so bind9 for me. Then when I hit return, we see the output here. But if I just use cat, that file that we've created at the end here, you'll see the output matches the contents of the file. So it's done what I've asked it, basically. Now, bear in mind, this is a secret. It's not a good idea to be showing people information like this. In fact, it's a terrible idea when it comes to security. In my case, yes, this is going out on YouTube, but it doesn't really matter for me. I want to show you what the output looks like, what the files look like, and so on. But obviously, even before this video goes out, this will all get changed. So this is not going to match what's actually going on. Even though this is a lab, it's in my own interests to use something completely different, because you never know. Anyway, now that that's done, we need to actually update the actual server. So I'm going to edit the config file, and I'm going to use nano to edit my file, name.conf.local. So you can see there's the line at the top already there that's referencing the actual key file that I've got. What we're interested in is this update policy here. So I've already got 2 lines. The first one is just to make sure that there's nothing out there can make any modifications to any type of record for this name. But that's the line that I've got for my DHCP servers. Now what I need to do is to add a new line in specifically for the actual ACME client. So I'm just going to tab this in. Then I'm going to paste in this. So I'm going to grant essentially any computer that's got this acme.key the ability to change text records, but not just within the actual zone homelab.lan that I've got, but also with any subdomain or subzone, if you will, because that's a requirement for ACME to work. It's not going to create a record, for example. Let's say we've got a server, www.homelab.lan. It's not going to be asked to create a text record for www.homelab.lan. I'm just checking it's going to be _acme-challenge.www.homelab.lan. So that's a subdomain. www really becomes a subdomain of this, if you will. And that's why we've got to put that in, otherwise it just won't work. So I'm going to save that. And for this to take effect, in my case, I need to restart the actual container. So I'm just going to bring the container down. And once that's done, I'll bring it back up again. Okay. Now I'm just going to just double check that that container is working, because it's very easy to put a typo. You might miss like a semicolon at the end or something, and then that's it. The container just won't work. So we'll just check. So it's been up for quite a while now. So it seems stable. If there'd been a fault, it would just keep restarting. So I'm going to clear that out. And then I'm just going to make sure that DNS does actually work. So I'm going to use the host command here to test a record on the internal network. Yep, so it's come back with the actual IP address of this Docker computer actually. But I'm also going to check that it's still doing forwarding out for internet computers as well. So in my case, I'm just testing it against a web server for Microsoft.com, for instance. So there, it's come back with that. So I know my DNS server still works, and now it should support dynamic DNS, at least for computers that know about that specific key. Now, before we actually configure an ACME server, it makes sense to actually check that our dynamic DNS updates are working first, and specifically with this new key. Reason being is that if anything does go wrong later on, at least we can rule out the DNS as the cause of the problem. Now, one way you can do this is to use the NSUPDATE command. Now, it might already be installed on your computer, but there's no harm in actually installing the package just in case. Now, this particular user doesn't have elevated privileges, so I'm going to swap over to a user account that does. As ever, because this is a Debian computer, I'll do sudo apt update first, just to make sure we've got up-to-date package information. Turns out I need to update some packages, but what I'm really interested in doing is either installing or at least making sure we've got DNS utils installed. So sudo apt install DNS utils, and then I've just got -y at the end to save me having to answer a prompt. Now I've already got that installed, so I'm going to swap back to our actual user for Docker. And what I'm going to do is to create a text file here, or at least I'm going to call it a text file. You can call it whatever you like, but it's called acmetest.txt, and I'm going to use nano to edit that. And then in there, we're going to copy and paste in a series of commands. Now, the first thing I want NSUPDATE to do is to actually connect to the proper DNS server. If there's an existing record, this one here, _acme-challenge.test1.homelab.lan dot, and that dot at the end is extremely important. That's the root domain in DNS. I want to make sure that that text record, if it exists, delete it. Then that way I can create my own text record. I'm going to give it a TTL of 600 seconds or 5 minutes, and it's going to have a value of, well, test record. I want to see the output, and I also want NSUPDATE to actually then send the actual commands as well. So we'll save that text file, and then we'll actually use NSUPDATE to reference the key that we've got. So acme.key, and we use -k for that. I'm using -v here, which the lowercase -v basically means for NSUPDATE to use TCP rather than to use UDP. The reason you would use that is if you've got, so like a lot of commands to actually send. But out of habit, I find it's better to just stick with TCP anyway. There's not a great deal of commands going across here, but there's no harm just to stick with TCP regardless. And then I'm just going to point it at my text file with all the commands in it. Hit return, and here's our output. Now, that line show that I was referencing in the text file, if you don't include that, you won't see this feedback. So that's the reason I've put it in there. Because what I wanted to know is that the status it came back was no error. And it's referenced what it's been up to there. So it looks like it's actually worked. But what I'm going to then do is to use the dig command just to be sure. So dig -t, so type txt. So I'm looking for a text record with that name. And again, that dot at the end is extremely important. Hit return, and we get all sorts of information. Important being status, no error. And then our answer section at the bottom gives you all of those details. In other words, that request actually went through, and we've now got a text record in there with that particular name. There's its TTL, its type internet, and that's its value. Now this is just a test. So what I'm going to do is I'm just going to get it to remove that record. So I'm just going to edit my little text file there. I'm just going to delete the actual line to add the record. So all we're going to do this time is to actually delete the record. So when we run that command again, so NSUPDATE-K, pointed to the key file, -v to use TCP, and then the name of the file, hit return. Now it's basically removed it. I mean, I can double check. So I'll run the dig command again. The status this time is NX domain. In other words, the DNS server has no reference to such a record. It doesn't exist. All it's coming back with is details about the actual DNS server itself. So that's good to see. But as a final tidy up, I'm just going to remove that text file. And I'm also going to delete my actual key because I no longer need to use it. But you can keep that there if you want. Just if you do, just make sure it's properly locked down and there's limited access to it, because that contains private information. But in any case, I know that if a computer's got that specific key, they can create text records on this DNS server. So I know dynamic DNS should work for these ACME clients.
Danger, Will Robinson, danger. Danger, Will Robinson, danger.
Now this next step is entirely optional. What I'm going to do is to get Caddy to create a completely new root certificate. Now you might ask, why on earth would I want to do that? I mean, I'll have to go around all of my web browsers, all my operating systems. I'll then have to update them with a new root certificate. That sounds like a lot of work. Why on earth would I want to do something like that? Well, the reason is because I've got multiple instances of Caddy, each in their own network segment for security reasons. It means that my web browser has multiple root certificates imported and they've all got the same name. So I can't easily tell which one's which. So just to show you what I mean, if we use OpenSSL here, so OpenSSL x509-text-no-out-in and pointed to the certificate I got stored on the actual computer here. When I look in the web browser, that's all I see in the certificate, at least at first glance. I mean, it would be possible to work out which one's which, but it'd be a lot easier if this name was unique on each certificate, but it's not, because this is what the default name is. So for me to change the name means to create a new root certificate. So yes, it's going to require a lot of work to do in all the maintenance on all those computers. But for me, it makes a lot of sense because I've got multiple instances of Caddy. Now, if all you've got is just one computer running Caddy, one container, then by all means just skip ahead. It's probably not relevant to you, but it might be useful all the same. So what do we need to do then? Well, the first thing to do is to edit the actual configuration file for Caddy, which is called Caddy file. So I'll use nano to edit that. And then I'm just going to make some space because I'm going to copy and paste in some global settings. So this is how we do global settings for Caddy. Now, just to point out, this all has to have tabs. I'm just checking, otherwise it starts complaining of formatting problems. I mean, it still works, but sometimes it causes a bigger problem, but sometimes it just complains of a formatting issue, which it'll then fix. That seems fine, but essentially what I'm doing is I'm using the global settings here to change the name for the local certificate authority when it comes to the PKI settings. Now, Caddy is capable of actually supporting multiple certificate authorities, but I just want to keep things simple. So I'm just going to change the name of the local certificate authority, and that's the only one I'm going to use. So we'll save that file. And then what I'm going to do next is, probably sounds drastic, but for me, it's the simplest way I can see of doing it. The reason being is we've got a root certificate authority, which signs the certificate for the intermediary, which signs the certificate for the servers, they're all stored on the actual data volume. They're all going to have to get replaced. I mean, the existing ones on service, for example, doesn't matter. The web browser trusts the existing root certificate as far as it knows. It'll still connect to the existing servers, at least until that certificate expires after about 12 hours at most. What we're going to do is create a completely new root certificate, new intermediary certificate, plus the keys, plus new server certificates. And then we'll update the browser and the operating system. And then going forward, all new certificates will get trusted because of the trust to the new root certificate. So like I said, it sounds drastic when you think about what you need to do, but this is the easiest way I've found of doing it. So first things first is we're going to bring down Caddy. So Docker compose down Caddy. It's connected to some networks for me, but it's going to leave those up and running. Now, what I want to do is to actually delete the data volume. But although I know what I've configured in the Docker compose file, I'm going to use Docker volume ls to list this, because what it actually does is it basically prepends the name of your Docker user to that volume. So that's the actual volume I actually need to tell Docker to delete. So although that's what I've told it I want within the actual Docker compose file, that's the actual name of the volume I need to delete. In which case, we'll run this command here. So Docker volume rm for remove, and then the name of that volume. And we could already do that while the actual Docker container is down. And then what I'll do is bring this back up again. So Docker compose up -d. So it's detached, running in the background. There we go, it's started that back up. Notice it's created a completely new volume for me. That I've found forces Caddy to basically start from scratch. Now, at the moment, it's not really a big deal because the instance that I've got is just running a reverse proxy anyway. So it's not a great deal to do. It was only doing it for one web server. I've got this WhoAmI one. But it's creating all of those necessary files from scratch. And like I say, that's the easiest way I can think of doing it, rather than going around and finding individual files to delete and so on. Now what we're going to do is just double check that this is up and running. So Docker ps-l. So that tells you about the last container that was started effectively. So it's not restarting, so that's a good sign. In which case, what I want to do is to actually grab a copy of this root certificate. So it's created a new one, so I'm using Docker compose copy, then I'm pointing it to the actual root certificate within this long path name, and I'm going to get it to create a new file within my folder called labdemo-root.crt. That makes even the root certificate easy for me to understand what it's for. So it's then copied that. Now if we use OpenSSL, we can take a peek at that certificate. So OpenSSL x509-text -no out -in, and this time I want to see what we get with this lab demo root certificate. So even though it's still tagging this bit on the end, notice how we've now got lab demo CA. So now when I go into a browser, I'll be able to see a very specific name on a certificate. And this for me is going to make life a lot easier when it comes to managing root certificates. Except now I'm going to have to go around all of my computers and, well, update them. Now setting up an ACME server in Caddy is actually pretty simple. What we're going to do is to edit the Caddy file, and I'll just use nano to do that. I'm going to go right to the end so that I can copy and paste in some details for our ACME server. So I'm going to present this as acme.homelab.lan because homelab.lan is the actual domain I'm using for my lab here. I'm calling it ACME because it's an ACME server, but you can use something completely different. Entirely up to you. I want a secure connection between the client and server, so we're using TLS, and we want our internal certificate authority to take care of this. And then we come to the actual ACME server settings, which are actually quite brief, really. So we say we want an ACME server behind that FQDN there. But I want to change the default challenges because by default it will be trying direct connectivity, which normally in my network I'd be blocking anyway. I want it to use DNS instead. So rather than trying to connect to the HTTP server or the HTTPS server, we want ACME to try a DNS challenge. So I'm limiting it specifically to DNS challenges only. Now this is entirely optional, but makes sense for security. I'm going to limit this so that the ACME server can only hand out certificates for this specific domain, homelab.lan. I mean, I can't be that specific when it comes to the actual host name. There could be lots of different names I come up with over time. So that's why I've got a wildcard there. To be fair, the DNS server that I've got would only allow records for homelab.lan anyway, but there's no real harm adding an extra layer of security. Usually does help, so that's why I'm putting it in there. But unlike the Bind9 server, I can actually lock this down to IP addressing. So I've got IP ranges, and then that's the actual subnet that I'm going to allow to connect to the ACME server. Now, if you do want to have more than one subnet, basically you would space them out, so 192.168. blah blah blah. So you can put multiple subnets on there if you like. For this demo, I'm just going to stick with one. But sometimes copying and pasting doesn't entirely go to plan, so I'm just double checking that these are all tabbed out. That seems fine. And that's it. That's basically our ACME server now defined. So I'm going to save those changes. Now, what you could do is you could actually just restart the container if you want, but you can actually get Caddy to reload its configuration while it's already running. So for me, because it's a Docker container and I'm using Docker Compose, I can do Docker Compose exec Caddy. So Caddy is the name of the actual container. And then basically this is the command we're going to run here. So Caddy reload --config, and then we tell it where the config file is. So /etc/caddy/caddy file. So I hit return. It actually reloads that config file on the fly. Now, for me, it's already up and running, so I don't necessarily need to check, but there's no harm. You never know if there's an actual error. I mean, I didn't get an error return, but let's just double check. Yeah, it says it's been up and running for 2 hours because we haven't officially restarted this. The only thing is, I've now created what is considered to be a web server, basically, but none of the computers on the network know anything about this. So what I need to do is to update DNS so they can resolve the FQDN. I'll just clear that session there. And I want this text file because I can use NSUPDATE. So we don't need that entry there. I'm just going to take that out. I'm going to give it some new commands. So again, I want to connect to my DNS server in this lab. I want to delete any existing record for acme.homelab.lan. Do remember the dot at the end, it's very important. And then I want to tell it to add a new record. I'll just set the TTL to be 5 minutes, and then there's the IP address, so it's an A record. So we'll save that. Then what I can do is use NSUPDATE to push that change out. So for me, I've got a file ddns.key at the moment, which contains the key that's needed for making dynamic updates for DHCP servers. -v, so we use TCP, and I'll point it at that text file, nsupdate.txt. So it hasn't come back with an error. So what I should be able to do then is just do a quick check and see if we get anything back using curl. Now, just to point out, this computer should be trusting the root certificate because I went out and updated my computers, but we shall see. So there you go. It hasn't actually come back with an error. That's the key thing. It's coming back with various bits of information, but the main point is it hasn't come back with an error. So in this particular case, we should now be able to use this ACME server and we should be able to now start configuring ACME clients to get their certificates. So for me, Caddy now acts as a reverse proxy for my containers, and it automates certificate management for computers that support ACME. Even some other Caddy instances can get their certificate from this Caddy server. Now, in theory, I could extend this further and have Caddy provide manually applied certificates. In other words, there are some devices that can only be updated manually. Practically, these certificates would need a longer lifetime of maybe 1 year, and although Caddy did have a bug when I last checked, hopefully that's now fixed and we're no longer limited to 12-hour certificates. That would then leave me needing only one root certificate to access all of my internal devices.